Hello and welcome to another AQA GCSE revision video. In this video we're looking at the 8300 series past papers. This is the first paper in the higher tier. It is a non-calculator paper, so we're not allowed to use calculators. And we're picking up, and this is the May 2017 past papers, and we're picking up in question 27. It reads, P, which is negative 1, 4, is a point on a circle centred O. Work out the equation of the tangent to the circle at P. Give your answer in the form of y equals mx plus c. Okay, so we have point P, which we know is negative 1, 4. And we don't have any other points. So how do we get an equation of this? Alright, well, I think the only way we can do this is to draw a line from the origin to point P. Now we do have 2 points now which can define a line, because you need a minimum of 2 points to define a line, and we can define this line, which is from the origin to point P, which is on the circumference of the circle as well as the tangent line. And we know that a line that goes from the centre of a circle to the circumference is the radius. Now the radius meets a tangent line at 90 degrees. And now we have all the information we need to solve the problem. So we've got the 2 points, 0, 0 and negative 1, 4. So if I say y sub r for the radius is equal to m sub r plus c sub r, and that's the equation for the radius. And we don't need c sub r because it goes through the origin, so there is no y-intercept, or there is a y-intercept, it's just at 0, so we can get rid of that. So all we need is the slope of the radius. Well, the slope is rise over run, so it's going from 0 to 4, and it's going from 0 to negative 1. So that's equal to minus 4 over 1, which is equal to negative 4, or minus 4. Okay, now we know that the slope of the radius is negative 4, and it meets the tangent line at 90 degrees. And where two lines are perpendicular, that is to say where they meet at 90 degrees, the product of the two slopes is negative 1. So if I say that the slope of the tangent line, which is mt, I'm going to put mt. This is just my choice. You could call it Bob or whatever, you know, it's up to you. So times mr, it's just whatever helps you remember, is equal to negative 1. And we know the slope of the radius is negative 4, so negative 4 times mt is equal to negative 1. So mt is equal to negative 1 over negative 4. Two negatives cancel out, so that's equal to 1/4. So the slope of our tangent line is 1/4. So our equation goes y equals 1/4 x plus c. Now we just need to find c. Well, the way to do that is to plug in our values for y and x. Now there's only one point on this line, so there's only one point to plug into the equation, so that's negative 1, 4. So when y is 4, x is negative 1. So 4 is equal to 1/4 times -1 plus c. So 4 is equal to -1/4 plus c. So all we have to do is take this -1/4 and take it over the other side of the equals, or we could say we're adding 1/4 to both sides of the equation. So 4 and 1/4 is equal to c. And now we have our full equation of our line. So y is equal to 1/4 times x plus 4 and 1/4. And that's all we need to do for our full 4 marks. You can write this in another way if you like. You could have said y is equal to x over 4 plus, well, you could have said 4 and 1/4, or 4 times 4 is 16 plus 1 is 17, so you could have said 17 over 4, or you could have written that as 4.25. That would also work. Y. You could even write y equals 0.25 x plus 4.25. Any of those ways of writing it would have been fine. What you mustn't do though is multiply everything through by 4 in order to simplify, because you might be tempted to say, oh, but this looks so much neater. 4y is equal to x plus 17. Isn't that neater? Aren't I clever? Yeah, you try doing that, you'll actually lose a mark, because the question specifically asked, write it in the form of y equals mx plus c. It must be in slope-intercept form. So don't be tempted to show off and lose a mark. Okay, I hope you found that helpful. If you're taking your GCSEs this year, I'd like to wish you every success with your revision and every success with your exams, and I look forward to seeing you in another video.